Welcome. This is Algebra 1B, Part 2, Sample Work, Unit 2. Unit 2 Sample Work, so it's vocabulary. So make sure to write each word, each definition, and sketch each example, and then submit your work turned in on a sheet of as a picture of your paper attached to a webmail. I'm just going to walk through the lessons and do them in order of the lessons. So we'll start here with Unit 2, Lesson 1. And we go down to, it looks like there are 3 keywords: radical expression, radicand, and rationalize the denominator. So the first word, radical expression. Radical. This is harkening back to my days of high school. Radical was... We didn't say rad yet, that came later, but we said radical, dude. Everything was radical. Radical expression. Okay, it's expressions containing a radical. Like that. Example, square root 4 equals 2. Okay, radical expression. Radicand. The square root symbol. Oh no, not the square root symbol. It's anything under the square root symbol. In this example, 4 is the radicand. Radicand. Rationalize the denominator. That is to get rid of the square root in the bottom of a fraction. Example, 5 divides square root 2. We multiply top and bottom by square root 2. And we get 5 root 2 over 2 because the square root times itself is just itself. Rationalize the denominator. That's it for Lesson 1. Lesson 2, operations with radical expressions. Okay, let's go here. Keywords, there are 3. First word is conjugates. Conjugates. Okay. Basically, it is a pair, a binomial pair, in which the second term, or second terms, are opposites. So 2 plus square root 3 and 2 minus square root 3 are conjugates. And when you multiply conjugates, you end up getting a simplified problem. It's basically the difference of squares pattern that we learn about. Like radicals. Same radicand, same radical. Square root 5 plus 2 square root 5 are like radicals, so they can be added to make 3 square root 5. They're like radicals. Unlike radicals. Different radicand. So 2 square root 6 plus 3 square root 5 cannot be added. They are not like radicands. Not like radicals. Can't simplify it. They're unlike radicals. Okay, that's lesson 2. Let's go to lesson 3. Graphing square root functions. Keyword, square root function. Okay, y equals square root x, or f of x equals square root x. F of x can replace y. Okay. Example, and I'm going to give the graph. Y equals square root x. The square root of 0 is 0. Square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. And so the graph looks like this. It's a parabola, half of a parabola on its side. Square root function. Translate graphs of square root functions. As no, that's an objective, not a keyword. Okay, so lesson 3 becomes lesson 4, which is mid-unit review. Lesson 5, reviews don't have new words. Lesson 5. I have 4 new words. Cumulative frequency table. We get into statistics here. Cumulative. And I'm going to change the order here because it's better to talk about frequency first. How many times an event happens is frequency. And I'm going to give an example for all of these here together. Frequency, cumulative frequency is not an option here. Frequency table, a table of bins with frequencies. Okay, frequency table, and we'll do cumulative frequency table. Okay, as a third column, totaling that row, or latest row, totaling the latest row with all previous rows. And histogram, a graph made from a frequency table. You notice I haven't done any examples yet because I'm going to do all the examples from the same example. So let's make some room here. Okay, so let's say we've got the following data. Okay, on Monday, actually let's do it this way here. I have the following test scores: 97, 96, 80, 81. Actually, let's do 81, 80. I'm going to keep them in order. 72, no, 78. 76, 76, 72, 65, 60, 58, 31. Okay, those are our test scores. So we'll have our bins, which are one, and I'm going to count up from 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. And when there is when a number occurs on the boundary, it always goes up to the next highest bin. Frequency. Okay, we have a 97 that goes in this bin. 96 goes in this bin. 81 goes in this bin. 80 goes in this bin. 78 goes in this bin. 76 goes in this bin. 76 and 76 and 72 and 65 and 60 and 58 and 31. Okay, so the frequency is 1, 0, 1, 2, 5, 2, and 2. That's our frequency. Okay, our cumulative frequency. Cumulative frequency, let's leave it just there, is 1. And then we add 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 2 is 4. 5 plus 4 is 9. 2 plus 9 is 11. 2 plus 11 is 13. So that's a cumulative frequency table. Okay, and a histogram. Okay, let's make our first column for 30. 40, 50, 60, 70, 80, 90, 100. Let's do it every other one. 40, 50, 60, 70, 80, 90, and 100. Actually, is the audio set right? I certainly hope so. All right, 90, 100. Okay, frequency is 0, 1, 2, 3, 4, 5. For 30 to 40, the frequency was 1. For 40 to 50, the frequency was 0. 50 to 60, the frequency was 1. 60 to 70, the frequency was 4. 70 to 80, the frequency was 5. And actually, sorry, the frequency was 2 for that one. or 60 to 70. 70 to 80, the frequency was 5. I would have looked at the cumulative frequency instead. That was a mistake. 80 to 90, the frequency was 2, and 90 to 100, the frequency was 2. Okay, and so let's do the graph, or histogram. Okay, so we've got our vertical bars. And note that there's no spaces, no empty space between the bars in a histogram. Histograms are not supposed to have empty spaces. Okay, and let's get our horizontal lines. Okay, our 5s, our 2s. And you can also do a cumulative frequency histogram as well. But I'm just doing a regular histogram here. And our 0s. Okay, so that's an example of a histogram. Right, so we made examples for each one of those. Okay, that's unit, or lesson 5. Lesson 6. Lesson 6 has quite a few keywords, so let's go there. Need to scroll up to make room here. Lesson 6, we're getting into mean, median, mode, range, and all of that. Okay. So, mean. The arithmetic average. If I gave you 3 numbers, 3, 7, and 11, and asked you to find the mean, you do 3 plus 7 plus 11 divided by 3, because there's 3 of them. 21 divided by 3 gives you an average of 7. The mean is 7. Okay, the median, I'm going to skip around here a little bit. Median, middle number. Okay, so if I gave you 3, 7, 6, or no, 3, 7, 9, and 10, the middle actually occurs in this case between 7 and 9. 7 plus 9 divided by 2. You average the two middle numbers, you get 16 divided by 2, or 8. Median, middle. If there's one number in the middle, you take that. If there's 2 numbers in the middle, you average them. Mode. Most popular. Let's say we have 3, 7, 7, 8, 11, 16. 7 occurs twice, so 7 is the mode. Most popular. Range. Now it says range of a set of data. I'm just going to do range. Okay, it's the highest minus the lowest. So in 3, 7, 7, 8, 11, 16, the range is 16 minus 3, or 13. Okay. Measure of central tendency. Measure of central tendency. So when you're given a list, where's the middle, kind of, right? The measure of center. It's the center of a list of numbers. And there are different kinds, including mean, median, mode, mean, median, and mode. That's pretty much it. Okay. Example. The mode of, or let's do the median. The median of 2, 5, and 6 is 5. That's an example of a measure of central tendency. Mean, median, mode, and mode are measures of central tendency. And measure of dispersion. It's a number that tells you how spread out a list is. Okay, examples. The range, or the interquartile range that you're going to learn about in this unit, or something called the standard deviation, which you're not going to learn about in this unit. Okay, and if I have the numbers 3, 7, 7, 8, 11, 16, the range, a measure of dispersion is 16 minus 3, or 13. Okay. And I think I've got them all. Yep. A lot of words in lesson 6. All right. Lesson 7, box and whisker plots. Keywords. Oh, there's a few. And again, as there are, we'll multi-purpose some of the examples. Okay, so here we go. Box and whisker plot. And quartile, and yeah, let's put quartile first. Quartile. A number dividing a list into fourths. Okay? And I'm going to give an example here in just a minute. Let's see, box and whisker plot. A graph showing min, quartile 1, median, quartile 2, or not quartile 2, quartile 3, and max. Okay, let me take a list here. We'll make up a list here for our examples. Let's say I have the list 2, 3, 7, 12, 15, 15. Actually, let's do 15, 18, 27, 32. Okay? There are 1, 2, 3, 4, 5, 6, 7, 8 numbers. So to find the middle, I'm going to count off 1, 2, 3, 4. 1, 2, 3, 4. The middle is halfway between 12 and 15, so we find the median. 12 plus 15 divided by 2 is 12, and 15 is 17 divided by 2 is 8.5 or 8.5. That's the median. The middle of the lower half is between 3 and 7, so 3 plus 7 divided by 2 is 10, divided by 2 is 5. Okay, so this is the median, and this is quartile 1, and the minimum is 2. The middle of the upper half is between 18 and 27. 18 and 27 is 30, 45. Divided by 2 is 22.5. That's quartile 3. And the maximum is 32. So to make a box and whisker plot, we need a number line that extends over this. So let's start at 0 and 10, 20, let's see, 1, 2, 3, 4, 5, 10, 1, 2, 3, 4, 5, 20, and 1, 2, 3, 4, 5, 30. Okay, make a number line based on that. You got to figure out what you're going to count by, what your scale is going to be. And then you put your 5 numbers above the graph here. So 2, that's right here. And 5 is half of 10. And 8.5, so this is every 2, this is 8. 8.5 is right here. 22.5, 22.5 is right about here. And 32, right here. Okay, and we put a whisker between the last 2 and the first 2 and the last 2. We put a box in between the second and the fourth. And then we draw vertical lines at each of them. So these are the outside parts are the whiskers, and the middle part's called the box. Box and whisker plot, quartile 1, quartile 3, so we have our examples for those. All right. Percentile and percentile ranks. Oh, interquartile range. Interquartile range. Interquartile. Sometimes called the IQR. It is quartile 3 minus quartile 1. In this case, it is 22.5 minus 5. It can be thought of as the width of the box. And that is 17.5. Interquartile range. Okay, percentile. It is what percent is less than or equal to a number in the list. Okay, example. Okay, this is known as the 0th percentile, the 25th percentile, the 50th percentile, the 75th percentile, and the 100th percentile. Because for 2, 0% is less, and that shouldn't be less than, absolutely, yeah, well, absolutely less than, not or equal to. The number 5, 25% or less than that. The number 8.5, 50% or less than that. And the number 22.5, 75% or less than that. and 32. Now this is kind of, there's a little bit of fudge room here. The 32 is the 100th percentile. It actually should include or equal to. Okay, and loosely those are the percentiles of the box and whisker plot. Percentile rank. Okay, percentile rank. Where a number or score falls compared to the other numbers. Okay, percentile rank. So the number 27 in our list is greater than or equal to 27, 1, 2, 3, 4, 5, 6, 7 out of 8 numbers. 7 out of 8. I should know this off the top of my head. 7 out of 8 is a decimal. 87.5%. 87.5%. So its percentile rank is 87.5. Okay, now let's see what else there is. That was lesson 7. Lesson 8 is a unit review, so that's it. Okay, this one had a lot of words. All right, make sure to send me or take a picture of your page and send that in.